Hello again, everyone. Today's video is going to be all about solving equations. We're going to look at a couple of different methods for solving linear equations, and then we're going to turn our attention to solving systems of linear equations. In the first example here, we see that we have a variable on both sides of the equal sign. So we're going to definitely want to try to combine our like terms. Since we're crossing an equal sign, we're going to be using opposite operations in order to do so. So I like to try to keep my variables positive whenever possible. So I'm going to choose to subtract 6a from both sides. That way it eliminates on the right-hand side. Left-hand side, I end up with just 1a. Subtract 3 equals 3. And then to solve for the variable, I'm going to add 3 then to both sides, and I get that a is equal to 6. From here, you can always check your answers if you're not certain that you did it right, or you just want to ensure, right, that we're going to get 100 on any sort of an assessment. Always a good chance, or good choice, excuse me, to check your answer. So 7 times 6, subtract 3. I'm going to take a moment to see what that equals. And then I'm also going to look at 3 plus 6 times 6. As long as I do this correctly, my answers for both the left and the right side are supposed to be equal to each other. So order of operations, 7 times 6 is 42. 42 minus 3 is going to give me 39. The second expression right there, 6 times 6, order of operations is 36. 36 plus 3 is going to, again, give me 39. Because these are both equal to each other, I am very confident that my answer of A equaling 6 is appropriate. Moving down to our second example here, we see we have some distributive property that we're going to have to use first. So 7 times 5a is 35a. 7 times negative 4 is going to give me negative 28. Bring down everything else. Subtract 1 equals 14 minus 8a. From here, I do have some like terms that I will combine on my left-hand side since these are on the same side, right? I'm just combining them. So that's negative 29 equals 14 minus 8a. And then again, very similar to the last problem, I'm going to add 8a to both sides, which is going to give me 43a. I'm going to add 29 to both sides, which is again going to give me 43. So when I divide here, I end up with a is equal to 1. Again, we can go ahead and check our answers if we would like to. That way we know if we did it correctly. And when we do, we'll see that we get the same answer on both the left and the right side. So let's scooch down and let's look at another example. This time we see one with a fraction in it. So that fraction is attached to a variable, so we do want to isolate that first. So my first step is just going to be to add 6 to both sides. So 8 plus 6 is going to give me a 14. And then from here, to get rid of the fraction, we can do it in 2 steps. I like to get rid of a fraction by multiplying by its reciprocal. So that means I'm going to take 7/8 and I'm going to multiply it by the reciprocal of 8/7. So look what happens when I do this. If I multiply 7/8 by 8/7, multiply fractions, you just go straight across. So 7 times 8 is 56. 8 times 7 is 56. So 56 divided by 56, any number divided by itself is always equal to 1. And that's why I like the idea of multiplying by the reciprocal in order to get rid of the fraction here. If you don't like that, if you're not comfortable with it, that is completely fine. You can also choose to multiply both sides of the equation by the denominator. Multiply both sides by 8. And then from there, your final step will just be to divide both sides of the equation by 7. So what I'm doing here in one step, you could also be doing in 2. Is your level of comfort, so you do you. All right, I'm going to multiply by 8/7. I'm going to multiply by 8/7. So like we've already discussed, left-hand side cancels out, and I'm just left with y. On the right-hand side, 14 times 8/7 is going to give me 16. Again, not comfortable with that, please feel free to go use a calculator. So if we do here, it's 8/7, and we can multiply that by 14, and we get our answer as 16. All right, so use a calculator whenever you feel like you need to. And again, you can always check your answers to make sure that you did it correctly. All right, so if you haven't had a chance to hit pause yet and try either any of the problems by yourself, please feel free to do that now. Hit pause, try these two, and when you are ready to check your answers, you can go ahead and hit play. All right, so I had already done these problems out, so I'm just going to select these. We definitely, again, need to use our distributive property as the first step. So I'm going to distribute that 2 to both the x and the -5. So you see that in my first step here, that's where 2x minus 10 came from. From there, I had some like terms. I know that 2x and 6x are going to combine to make my 8x. From there, I need to isolate my variable. So I can add 10 to both sides, which is where 18 comes from. Oh, I have a little bit of a typo right there. So let's get rid of that. There's definitely no A's in this problem. So once I add 10 to both sides, I get 18. And then I divide both sides by 8. So 18 over 8 does reduce to 9/4, which is also equivalent to 2.25. So if you leave your answer as 9/4, it's 100% correct. If you leave your answer as 2.25, again, 100% correct. If you leave your answer as 18 over 8, I will be taking off partial credit because that is not a fully simplified answer. Keep in mind your calculator does naturally reduce fractions for you. So if we enter in 18 over 8, we get that same 2.25 that we spoke about before, but then your calculator will reduce the fraction if you hit the alpha key and then enter twice. See, our 18 over 8 reduced to 9 over 4. So math enter enter will convert any decimal into its most simplified fraction form. If we look over back to our second example now, we see that we have two separate denominators. We have a 3 and we have a 5. So 3 times 5 is going to give us 15. So that is why I'm going to use 15 as my lowest common denominator. And I multiplied every single fraction by 15 to start with. I'm having a little bit of trouble. If we multiply everything by 15, that's going to get rid of our fraction in the very first step. So 15 times x over 3 is going to give us 5x. 15 times x over 5 gives us 3x, keeping that minus sign in the middle, and then 15 times 2. Keep in mind when you're doing this method of multiplying by that lowest common denominator, you need to make sure that you are multiplying everything, including the side over to the right here. A lot of people have the tendency to multiply this one and this one by 15, but then somehow this guy gets forgotten about. So make sure we distribute the 15 to every single term. From here, it's just combining the like terms of the 5x and the 3x, which gets us 2x, and then dividing by 2 to get a final answer of 15. All right, so those are some examples of how to solve equations. Now we're looking at systems of equations. And when we solve a system of linear equations, we can do so using a substitution method, elimination method, or a graphing method. We're going to focus for right now on just the two algebraic methods, the substitution and the elimination. We'll talk about graphing at a later date. So if we're looking down, we have 4 sets of problems here, and we know we want to use the substitution method if one equation is already solved for a variable, or at least one of the two equations has a variable that's very easy to solve for. So if we look at the 4 equations here, do you see any systems of equations that has a variable that's already solved for it? If we identified this equation here as having a variable that's already being solved for, you are correct. If we identified this system of equations already having a variable solved for it, you would again be correct. Those two will definitely use a substitution method to solve for. So if we go through the steps of actually solving this first problem here, this first system, we know that an answer to a system of equations is always a coordinate. It's an x value, comma, a y value. So the y we already know, we're told here y is -2. I'll put that in the y spot, and then all I have to do is substitute that value in, hence called the substitution method, substitute that y value in, and then just solve for x. So 4x minus 2 times -2 equals 8. So let's do a little bit of math here. -2 times -2 is going to give us a positive 4. Okay. And then I can subtract 4. and then divide by 4. So we know that x is equal to 1. So our answer for this first system of equations is going to be 1 comma negative 2. When x is 1, y will equal negative 2. If we turn our attention now over to our second set of problems, we know what y equals. It's just not as easy as the first one, right? It's not equal to a specific value like negative 2. Y is equal to an expression. It's equal to the expression 5x plus 4. So we can replace the y, or substitute in for y in that second equation. We're going to replace it with that 5x plus 4. So I end up with 5 over 7x plus 4 equals, replaced over here, and then I have my right-hand side, negative 1 over 7x minus 2. And now, similar to the last problems that we saw whenever we have a fraction, if we want to get rid of them in the first step, here our fractions are both the same. They're both 7, so we can in turn multiply everything by 7. I'm going to say be careful here. If we're going to choose to multiply everything by 7, we have to multiply a 1, a 2, a 3, 4 terms all by 7. Be careful and make sure that you hit every single term that's there. So 7 times 5 sevenths is going to give us 5x. 7 times 4 is going to give us 28. 7 times negative 1/7 is going to give us negative 1x. And then 7 times negative 2 is going to give us negative 14. So again, be careful, distribute to everything, and always watch your signs. In order to solve from here, I'm going to choose to add 1x to both sides. So it gets me 6x. I will choose to subtract 28 from both sides, which is going to give me 20, 30, 42. So when I solve here, I get that x, when I divide both sides by 6, is going to give me negative 7. So I know when I start writing my answer, I know that negative 7 is going to be the x value. And now I could plug in negative 7 into either equation for x to figure out the value of y. So if I turn to the first equation, 5 sevenths times negative 7 is going to give me negative 5. Negative 5 plus 4 is negative 1. A little check right now, if I plug negative 7 into the bottom equation, negative 1 over 7 times negative 7 is a positive 1. Positive 1 minus 2 is negative 1. Because again, we got that same answer. We are pretty confident. We're very confident. Actually, we're not pretty confident. We are very confident that our answer here is going to be negative 7, negative 1. All right. Let's take a look now at the elimination method. So the other two equations that we have here that we haven't yet talked about, we can solve those by substitution if we would like to. We do have a variable that's pretty easy to solve for, right? We could solve for the y in the first problem, second equation. Similarly, we could solve for x pretty easy. Again, second problem, or third problem, excuse me, the second equation. So we could easily solve for those variables, and then we could go ahead and we could do a substitution method. It's possible. All right, but I also want to show you the elimination method. So I'm going to take those same two problems, and I'm going to do them down on the next page using that elimination method. So for the elimination method, I want to make sure that both equations first off are in standard form. The x's line up with each other, the y terms line up with each other. From here, you have to multiply one or both equations by, it could be the same value, it could be different values. Your goal is you want either the x's or the y's to eliminate. So if we look here at this problem, we have choices. We could choose to multiply the top equation by 2. If I multiply everything by 2, I'll see that 4 times 2 will give me 8, in which case my x's will eliminate. Similarly, I could also multiply the second equation by 3 or negative 3 to attempt to get the y's to eliminate. Again, the choice is yours. There is not any method that's more correct than the other. It is simply your comfort level. All right, I am more comfortable with multiplying the top equation by 2, so I'm going to choose to do that. So I need to make sure that I multiply every single term by 2. So I'm just going to notate that here that I'm multiplying by 2. So 4 times 2x is 8x. 2 times 3y is going to give me 6y. And 2 times negative 8 is going to give me negative 16. All right, I'm going to take that second equation now. I didn't touch it. I don't need to. I'm just going to copy it down. And then I see that I have a positive 8x and a negative 8x. If I add those together, they eliminate each other, right? And that's the purpose of this elimination method here. So let's go ahead and let's add our rows. When we do that, we already talked about it. The x's eliminate. Y's, I end up with 6y plus 1y. You can put a 1 there if you want a placeholder. Gets us 7y. On the right-hand side now, if we add these together, again, be careful with your negative sides here. A negative 16 plus a negative 12 is negative 28. If I divide now, I get that y is equal to negative 4. All right, so from here, let's go ahead. And now we need 2 answers, right? We need to still solve for x. So I'm going to start writing my answer over to the side. Y is going to be negative 4. And now I have choices. I can go back and substitute in negative 4 for y in either the top equation or the bottom equation. Again, your level of comfort and whichever one you think is easier. I think the bottom one equation is a little bit easier here because the y is all by itself. I don't have to multiply anything. So that's going to be my choice. So negative 8x plus negative 4, or just minus 4, is equal to negative 12. I'm going to add 4 to both sides, and I'm going to divide by negative 8. So I end up with a positive 1. So my solution here is 1 comma negative 4. Great. Let's do this one more time. So one more set of equations here. Again, if you want to try this on your own first, go ahead and hit pause and then hit play again when you are ready. So let's think some choices here. I can either multiply my bottom equation by 3 and my x's eliminate. I can multiply my bottom equation by 2 or negative 2, either one, to get my y's to eliminate. So again, choice is up to you. Kind of like getting my x's to eliminate here. I'm making that choice honestly only because I see a positive 3x, and then at the bottom, if I multiply by 3, I'll have a positive 3x. So I have opposite signs is my only reason. It really makes no difference. It's not really that much extra to multiply by a negative, but that's my choice. All right, so I'm multiplying everything here by a positive 3. So first thing, I'm going to copy that top equation as is. I'm not touching it. I'm just copying it so I could use it in my next step. All right, now let's multiply by 3. 3 times x is 3x. 3 times negative 5y is negative 15y. 3 times 18 is 54. Use a calculator if we need to, if we're not comfortable, right? Don't want to make any errors or mistakes because then that's going to mess up everything else, right? So we're good to go. And let's take a look. We talked about already that our x's are going to be canceling. So they'll cancel by adding our 2 rows together. And negative 10y plus negative 15y is negative 25y. Negative 4 plus 54 is going to give us 50. And then dividing gets us that y is negative 2. So I'm going to start writing out my answer again, where y is negative 2. And then I just need to solve for x. So from here, again, top equation, bottom equation, either one is appropriate for plugging negative 2 in for y. We just want to think about whatever is going to make our life easier. And I think I'm feeling that bottom equation. I don't know, I like it. Totally, choice is up to you. I'm just seeing that that x is by itself, so it's slightly less work to deal with that second equation, but not a big deal either way. Negative 5 times negative 2 is going to give us a positive 10. So we know that x is equal to 8. We can plug that answer up there, and we are done. All right, so we went over today's solving equations using a variety of different methods, as well as solving systems of equations. Thank you for watching.